Hello everyone, today I'm going to teach you one of the chapters from maths, that is properties of parallelogram. This is for 9th standard students. Before I start solving questions from these chapters, I would like to welcome you in the online class. The first things which I'm going to explain today is the first theorem, that is theorem 15. This is from the chapters called properties of parallelograms. You can just find out this one in your book. So this is theorem 15. So the first theorems we got it here is, that is the diagonal of a parallelogram bisect each other's means what we need to prove. We need to prove that the diagonals of a parallelogram bisect each other's, right? So before, like some informations already I have written here, that is given two diagonals AC and BD intersect each other's at O in the parallelogram ABCD. Means we got the parallelogram ABCD. In this parallelogram ABCD, we got two diagonals, diagonal AC and diagonal BD. So they do means these two diagonals, diagonal AC and BD, they bisect each other's. This is what we need to prove it. Okay. So in the part of to prove, we got AO equals to OC. What we need to prove, that AO equals to OC. Then another one we got BO equals to OD. BO equals to OD, right? So before I start solving these questions, right, I would like to provide you some of the informations that is that we need to know in case of a parallelogram. In case of a parallelogram, in case of a parallelogram, what we know, that the opposite sides are equal. Opposite sides are equal. This is the first point. The second one, we have that opposite sides are parallel to each other's. Opposite sides are parallel. Opposite sides are parallel to each other's. Opposite sides are parallel to each other's. So these are the two informations which will be utilized while finding the while proving that the diagonals of a parallelogram bisect each other's, right? So we got it here, that is we need to prove that AO equals to OC. So where we got this AO equals to OC, right? Means we are talking about this side and this side, right? Then we got here BO equals to OD. BO equals to OD. We are talking about these two sides, right? So here, what we'll do it here, like we can take in triangle AOD and triangle BOD. So in case of part of proof, we'll take in triangle AOD, AOD and triangle BOD. BOD, right? We took the two triangles. Why we took the two triangles? Like if these two triangles can be proven as congruent, means we can say that that's AO equals to OC and BO equals to OD, right? So let's try to prove these two triangles congruent. Whether it is possible or not, let's check it out. We need to find the 3 points. So the first ones, what we'll do it here, that is AD equals to BD. Why? This AD and BD, AD equals to BC. AD equals to BC. They are the opposite sides, right? So right here, AD equals to BC. This AD equals to BC. Now what will be the reason? Opposite side. Opposite side, right? Opposite sides of a parallelogram are equals. This is the theorem's rules, right? Then we got here another things. We took this part, right? Now this angle, if you talk about these angles, what you'll find that these two angles are vertically opposite angles. So vertically opposite angles are also equal. So we write here angle AOD. Angle AOD equals to angle BOC. Angle BOC, right? So what will be the reasons? The reason will be vertically opposite angle, right? Vertically opposite angle. We got the 2 points. Now one more point we need. Okay, so one more point. What we know, the second point which I have written here, opposite sides are parallel, right? Opposite sides are parallel. So when we have two lines parallel to each other, and when we got a transversal over here, right? So what you understand, this angle and these angles becomes equal. Why? We call it as alternate angle. At the same time, this angle and this angle also will be equal. We say that alternate angle, right? So similarly here, we can take this angle equals to this angle, right? So we write here angle ADO. Angle ADO equals to angle CBO. Angle CBO, right? The region will be alternate angle, right? The region will be alternate angle. Alternate angles, right? So this is what we got. Like we got the 3 points, 1 2 3. That means we got one side and two angles. So we can say that therefore triangle AOD, triangle AOD is congruent to triangle BOD, right? BOD. By which rule they are congruent? So we got the two angles and one side, right? We say that angle side angle. Clear? We got the, means these two triangle we have been able to prove as congruent. Now once we prove congruent, now what we can say that side AO equals to OC. Therefore AO equals to OC. OC, right? Another things we can say that BO equals to OD. BO equals to OD, right? For both, what will be the region? The region will be CPCT, right? What do you call it as? CPCT stands for corresponding parts of a congruent triangle. So now we have been able to prove that the diagonals of a parallelogram bisect each other's, right? So we can say that therefore diagonals of a parallelogram bisect each other, right? Proved. So this is all about the first theorem. Let's take the another one. Okay, here I have taken a questions from your exercise 6, page number 108, right? The first questions is let us prove that if the length of two diagonals of a parallelogram are equal, then parallelogram will be a rectangle, right? Then parallelogram will be a rectangle. So what we need to prove that ABCD is a parallelogram, which I have written here in part of solution. Let ABCD be a parallelogram in which AC and BD are equal. Okay, this AC and this BD are equal. These and these are equal, right? AC and BD are equal. Now to prove ABCD is a rectangle, what we need to prove that ABCD is a rectangle, right? So in case of rectangle, what we understand, okay, in case of rectangle we know that, okay, in rectangle opposite sides are equal, right? In rectangle opposite sides are equal and each angle is 90 degree, right? Each angle is how much? 90 degree. Opposite sides are equal, right? So in case of parallelogram also, what we know that opposite sides are equal, okay? Opposite sides are equal, but each angles are, it's not 90 degree. It means here, if we can prove each angle is 90 degree, means we can say that this parallelogram ABCD is a rectangle. Here what is missing? Each angles are not 90 degree. In case of rectangle, each angles are 90 degree. In case of parallelogram, opposite sides are equal. In case of rectangle also, opposite sides are equal. But the thing is that we need to prove that each angle is 90 degree, right? Now for this, what we'll be doing, okay, we'll take in triangle ADC and triangle BCD, right? In case of proof, in triangle ADC, and triangle BCD, right? BCD. Clear? In triangle ADC, we are talking about this part, right? In triangle BCD, we are talking about this part. Clear? So here what we got that in these two triangles, the common thing that is we have CD and CD. CD is common, okay, here. CD equals to CD, right? It's common part. It's common for both the triangles, right? Now another things we got here, AC equals to BD, right? AC equals to BD. AC equals to BD, since it is given, okay? It's given in the question itself, so we write this is as given, right? Now another things, what we know that AD equals to BC, okay? AD equals to BC. This is the opposite sides. In my first theorems I had given you this one, okay, that is opposite sides of a parallelogram are equal. So we got the 3 points here. It means we can say that therefore triangle ADC is congruent to triangle BCD. By which rule this is? Okay, we got side, we got side, we got side. All sides we have got, so we say side, 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 right? So we got the two triangle as congruent, right? Now in triangle ADC we have this angle. In triangle BCD we have this angle, right? It means we can say that therefore angle ADC, right? Angle ADC is equals to angle BCD, right? Angle BCD. Clear? The reason will be again CPCT, right? Corresponding parts of congruent triangle. Now we got this one, right? Now what was missing in case of parallelogram and rectangle? Okay, in case of rectangle each angle is 90 degree, and now here is not 90 degree. But what we know that angle ADC and angle BCD, okay? Since angle ADC and angle BCD are adjacent angles. They are adjacent angles, right? So in case of parallelogram, adjacent angles add up to 180 degree. So we can say that therefore angle ADC plus angle BCD equals to 180 degree. This is one of the theorems, one of the rules we have in case of parallelogram. The adjacent angles always sums to how much? It's 180 degree, right? So here ADC and BCD are equal. So let's write here angle ADC plus, in place of BCD, what we can do? BCD is equals to angle ADC. We'll write here angle ADC, right? Equals to 180 degree. Now ADC plus ADC equals to 2 angle ADC equals to 180 degree. Then angle ADC equals to 180 upon 2. So 2 1s are 2, 2 9s are 180. Therefore angle ADC equals to 90 degree. So what we got here? We got this angle as how much? 90 degree. Now since these two angles are equal, so this will be also how much? 90 degree. Similarly we can say that these two angles are adjacent to each others, right? These two angles are adjacent to each others. Since angle ADC and angle BAD are adjacent, okay? Therefore we can say that angle ADC equals to angle BCD equals to angle BAD equals to angle ABC equals to 90 degree. So we can say that therefore parallelogram ABCD is a rectangle. It is a rectangle, right? So this is proved, right? So this is all about the solutions of these questions. I hope it is understandable, right? If there will be any doubt, I'll be available to you in your online classes. You can ask me. Thank you all.